Next, let's talk about composition of functions. So if f and g are a function, then the composite function or composition of f and g is f composed with, that's what this means, it's an open dot, but it means composed with g of x. So basically what this is telling us to do is substitute in g of x for x in f. And you've seen us substitute in equations for a single variable when we were solving equations by substitution back in chapter 3. The domain of f composed with g is the set of all numbers in x in the domain of g such that g of x is in the domain of f. Well, what does that mean? Let's describe that a little bit of a simpler way. After we practice composing some actual functions, then we'll dive deeper into the domain. So if I have f composed with g of 3, I like to rewrite this as f of g of 3. So what this is basically saying is I need to substitute 3 into g of x. And then I can plug what our resulting value, which is going to be 2/3 if I plug in 3, into g of x. So that gives me 3 times 2/3 plus 2. I'm substituting in that value for x. So that would give me 2 plus 2, because my 3's cancel, which is 4. So if I want to take f composed with g of x, I would take f of g of x. That means I'm substituting in the equation g of x, which in this case is a rational equation, in for x in f. So now I have 3 times 2 over x, because I substituted in for x, plus 2, so I get 6 over x plus 2 would be our composite function. So how do we find the domains of composite functions? Well, we find the domain of the composite function in 2 steps. So first, find the domain of the inside function. We call that the input function. That's typically our g of x. And if there are any restrictions on the domain, we keep them. Next, we go ahead and find the composite function. We find the domain of the new function. And if there are restrictions on this new domain, we add them to the restrictions from step 1. Right? If there's an overlap, we use the more restrictive domain or the intersection of domains, right? And the composite may result in a domain unrelated to either of the domains of the original functions, and that is totally okay. So what do? We take the domain of the input function, we find the domain of our new function, and if there are restrictions, we add them to the restrictions from step 1. So if I have f of x is 3x plus 2 and g of x is 2 over x, we're going to find the domain. We already found that this composite function a couple slides ago was 6x plus 2. So what's the domain of our composite function? So first let's find the domain of our input function. If I have my input function was g of x, the domain of this function would be all values of x as long as x doesn't equal 0, right? Because my denominator can never equal 0, because we can't divide by 0. 0 is the only value excluded from our domain. So let's go ahead and write that down. Next, I find the domain of my composite function. Well, here I have 6 over x plus 2. The domain of this composite function also has to be all values of x such that x doesn't equal 0, right? And are there any additional restrictions? No. So the domain of our final composite function is x such that x doesn't equal 0. In this case, the domain of our composite function was the same as the domain of g of x, but that's not always going to be the case, so consider this a warning. Okay, so let's go ahead and find the domain of g of x. So this is a rational function. This is a radical function. G of x is the square root of, I could write that as negative x plus 3. That shifts my that shifts my x values. So this is a, where'd it go? Remember this, if I have a negative in front of my x, that is a flip across the y-axis, right? So my graph is going to look like this radical. So when would negative x plus 3 be equal to 0, right? So I can figure out when my graph starts. Well, negative x is, subtract 3, negative 3, so I get x is 3. So the domain of g of x is going to go from as long as x is less than or equal to 3. Because my graph, right, here's my graph, this is 3. So as long as my x value is less than or equal to 3, we're good. Next, let's go ahead and find the composite function. I have f composed with g of x, so I have f of g of x, which would be substituting in g of x for my x and f. So I have the square root of negative x plus 3. I'm going to write it this way. I don't like the fact that there's a constant leading here. Squared plus 2. So I have the squares cancel out square roots. So I'm left with negative x plus 3 plus 2. So I have negative x plus 5. Well, you'd think the domain of this, we find the domain of this composite function. Well, this is a line. The domain of that composite function would be from negative infinity to positive infinity, right? All real numbers. That's the graph of any line with a positive or negative slope. It's going to be negative infinity to positive infinity. Well, g of x is restricted such that x has to be less than or equal to 3. So we're going to do the same thing to our domain, right? We add in the restrictions of which there are none. And because there are none, we're going to use the domain from step 1. So our domain is x such that x is less than or equal to 3.